We'll continue or finish section 3.6. Last time we learned how to find the asymptotes of a rational function, especially for linear over linear or constant over linear. And we said the vertical asymptotes of a rational function are the zeros of the denominator. Regarding the horizontal asymptotes, we said we have three cases. And the cases, you can see them on the screen right now. If the degree of the numerator is less than the degree of the denominator, we say the horizontal asymptote is y equal to 0, which is the part A in the rule that you can see right now. The part B, if the degree of the numerator is equal to the degree of the denominator, our horizontal asymptote will be what? Y equal the leading coefficient divided by the leading coefficient. And if the degree of the numerator is more than the denominator, we say the rational function has no horizontal asymptote. And we did some examples how to find asymptotes. Then after that, we learned how to graph. And we said to graph, we have to do these 5 steps. First step is to factor. Second step to find the intercepts. Then the vertical asymptotes. Then the horizontal asymptotes. Then we sketch. And I think we did 2 examples on sketching, which are these. Now today, we will learn how to graph a rational function if there is a common factor between the numerator and denominator. Let's see this first example. What does he say, Shabab? Graph the following functions. Let me start with the first one, which is s of x. Now in this function, Shabab, can we factor? Of course, the answer is
Yes, common factor.
yes. I can take x as a common factor. Can I cancel x minus 3 with x minus 3? And the answer is what now? 1 over x. But now, can anyone tell me the condition that we put? X should not be what?
0.
No, should not be 3. 0 is already, you can see it in the final answer, but I cannot see the 3 in the final answer. So who can tell me what's the domain for this function?
Negative 20 to 3.
To 0.
So should I just say except 0 or except 0 and 3?
0.
0 and 3.
Please mute your mics, the one who's making the music. So the domain are all real numbers except 0 and 3. And we took this earlier. We said we have to find the domain before we simplify. Type now, Shabab. For this function, which is 1 over x, how can I graph this? Y equals 1 over x. Do we know the graph? We took it last time, which is the basic graph of 1 over x. Let me graph this one quickly for you. I don't think that we need to discuss it. We made this discussion of 1 over x yesterday. And this is a very basic function, which means we need to memorize the graph. I'm just gonna put the graph in our notes and discuss what we need. طيب. Let me just do it here. This is our graph. And this is the thing that we have discussed earlier, last time. But now a question, Shabab. Of course, we have horizontal asymptote here, which is what's the horizontal asymptote in this graph?
It's 0.
X.
y equals 0, not x, horizontal. So the HA is y equals 0. But what about the vertical asymptote? We have x equals 0. But now, my function, is it defined at x equal 3?
No.
It's not defined. If it's not defined at x equal 3, I have to do something, Shabab. The graph is not correct now. I have to do something for my graph. What's that thing? Read this statement now. At x equal 3,
Make it open.
thank you very much. Excellent. The
Oh.
function is what is undefined because it's not in the domain, right? So here we make
Hole.
a hole at x equal 3. What does it mean, hole? So do you see the 3 here? I'm just gonna make a hole at 3. But of course I will just try to remove the curve at this point 3 here. So at x equals 3, what do I have here? A hole. And this hole means the function is undefined at x equal 3. So this is the new idea now. If there is a factor that we eliminate or delete, the zero of that factor makes a hole in the graph. If you have a question, raise your hand. Ali Saba, go ahead.
Yes. Why we don't say the vertical asymptote is x equal 3?
Because I have x equal 3 in the numerator, they cancel each other. Do you see x minus 3 up and down?
I saw that. Yes.
This means whatever we substitute for x, it will be always simplified. I can remove x minus 3 with x minus 3. So the vertical asymptote, we will find it after we simplify, not before. But the domain is before we simplify, not after. Why? Because the vertical asymptote, what does it mean? At x equals a specific value, the value of y will go to infinity or negative infinity. So as x approaches 3 here, the value of y will not go to infinity. As you can see from the graph. Look at the graph now. As x approaches 3, where is the value of y going? What's the value of y here? This value.
Less than 1.
1/3. So as x approaches 1/3, the value of y is approaching. Sorry, as the value of x approaches 3, the value of y is approaching 1/3. But in the vertical asymptote, as x approaches 3, the value of y should go to infinity or negative infinity. But here, this is not the case. It's not going to infinity. So that's why we don't have a vertical asymptote. So in simple words, when do I find the vertical asymptote? Before I simplify or after?
After.
After I simplify. Any other questions? طيب. Let's take the second one. What's the second one, Shabab? Do you see it? It says t of x equals to x to power 3 minus x squared over x minus 2. I want you to factor now and simplify and tell me where's the hole here. Yeah, factor this one. Is this the answer of the function? طيب. محمد الحارثي, factor this for us.
equal x square.
Again, repeat. Mute your mic. Repeat the factoring.
Yes, doctor. X minus 2 factor x square, right?
Continue.
And x negative 2.
طيب. Now, do we have anything to simplify, Shabab? So the answer is x squared. Now, but this thing that we have simplified makes a whole. So we will say at x equals what? We have a whole.
It's equal to.
At x equals 2, which is the zero of the factor that we have removed. So, do we remember how to graph x squared?
Yes, parabola.
Y equals x squared is a parabola, right?
Yes.
Do we have an asymptote for this parabola?
No.
No, so no, it's just a parabola like this. And again, where should I draw the hole?
X equal to.
At x equal to, and the value of y here is what?
4, approaching 4.
So I would say at 2, 4, there is a hole. And of course, I will just remove the curve from 4 here. This is our graph now. Again, there is a hole at x equals 2. Now, can anyone tell me when is this graph increasing?
From 0 to 2 and union to 2 to infinity.
Thank you very much. Excellent. From 0 to 2, then from 2 to infinity, because 2 should not be included. Osama, you're raising your hand.
I think so. About the domain, it will be from all the numbers except 2.
That's right. So domain is all real numbers except 2. We said the domain, we have to find it before we simplify. And the vertical asymptotes, we find them after we simplify. Okay? Hassan, what's your question, Hassan?
دكتور ليش يا دكتور هنا دكتور عندك دائرة مفتوحة دكتور؟
What does it mean a whole? It means the function is undefined at x equals 2. Let me write it down here. The function is undefined at. Now, if we substitute this 2 here in the function, what do you get in the basic function? Do you know what do we get? Yeah, Hassan, substitute 2 in the function. Tell us what will we get?
اوكي قيمة الاكس نحطها قيمة فارغة. Thank you دكتور.
What's the answer? Just give me the substitution.
اكس تساوي 2 دكتور.
Again, raise your voice.
اكس تساوي 2 دكتور.
I cannot hear you, يا شيخ. Raise your voice.
ما فهمت سؤالك بالضبط يا دكتور.
Substitute 2 in the function. Substitute means عوض. Substitute 2 in the given function. At x equals 2, what's the value of y?
Zero, right?
I want Hussam to tell us. Hussam, what's the answer for this?
اوكي 0 دكتور يساوي 0.
No, it's not 0. It's 0 over 0.
Yes 0.
And 0 over 0 is not 0, ya Sheikh. 0 over 0 is undefined. So which means now at x equals 2, what do we have? We have a whole. What does it mean, a whole? It means the function is undefined at that number. Why it's undefined? Because we have substituted, and you can see the answer is undefined.
Okay, Doctor, thank you. Think time.
You're welcome. So again, Shabab, when do we have a hole in our graph? Can anyone answer this question for us?
X equal to.
No, in general, I'm talking in general. When will we have a hole in the graph?
In the zero of denominator.
No.
If we
Zero denominator.
have 0 over 0.
Okay, when will this happen? If we have a common factor between the numerator and denominator. Do we have a common factor between the numerator and denominator here?
Yes.
So I will have a hole if we have a common factor between the numerator and denominator. A factor that can be removed, I mean. Any questions about the hole? Yes, Ali Saba.
No.
You are raising your hand. Okay, shut up. Let's now take some old exams on this section. Let's read this one. What does it say? If y equals -3 is a horizontal asymptote of the function y equals ax plus 3 over 1 minus 2x, then find the x-intercept. Now here he gave us the horizontal asymptote. And if you remember, we took 3 cases for the horizontal asymptote. Let me remind you with these, then let's get back to the question. Although we have covered them at the beginning of this lecture. Here, shown. In the first case, if the degree of the numerator is less than the denominator, we said the horizontal asymptote is y equals 0. And if the degrees are equal, the horizontal asymptote will be the leading divided by the leading coefficient. And if the degree of the numerator is more than the denominator, we said we have no horizontal. Now in our question, he said, what's the horizontal asymptote in the question?
-3.
So if he gave me y equal -3, can I say anything about the degrees?
Yes, equal.
Thank you. So the degree of the numerator is equal to the degree of the denominator, as you can see in the function. And also, do you remember how to find the horizontal asymptote from the equation here? We used to divide what?
The leading to
The leading by the leading. So I will say what now, Shabab? A divided by -2 should equal to what? -3. Can I find A?
6.
A is 6. So if A is 6 now, what's my function? Replace A with 6.
6x
Plus 3 over what?
Minus 2.
This is our function. Now, the question is asking us to find what? Find the
x-intercept.
x-intercept of the graph. And the x-intercept, how can I find it?
Replace y with 0.
Replace y with 0. So if we replace y by 0, what do we get now? 0 equals to 6x plus 3 over 1 minus 2x. Can I say 0 is 0 over 1?
Yes.
And we can cross multiply now. If we cross multiply, what's going to happen?
6.
We'll have 0 equals to 6x plus 3. So how much is x, Ishal? Is it -3 over 6 or not? Which is -12. And we are done with the question. Raise your hand if you have a question. Now, do you see a relation between the x-intercept and the 0 of the numerator? What was the x-intercept in my question?
-half.
-half. What's the 0 of the numerator? The 0 of the numerator, Shabab.
-half.
So can I give this as a rule that the x-intercept is equal to the 0 of the numerator? This is a rule that can be used later, or it can help us later to make things faster. Let's take this next example. What does it say now? He says find the equation of a rational function with vertical asymptote x equal 4 and horizontal asymptote y equal -1 and an x-intercept 3, 0. Of course, he is asking about what now? A rational function. But since we are given a vertical asymptote, Shabab, from the vertical asymptote, can I make a denominator? Don't forget the vertical asymptote is the 0 of the denominator. So what should I write in the denominator here?
X minus 4.
X minus 4. Why, ya Shabab? Because we said the vertical asymptote is the 0. Sorry, is the 0 of the denominator, yes. طيب. Now, our horizontal asymptote is given to be -1. How can I find it in general if I have the equation? We use to divide what, ya Shabab?
minus x.
The leading by the leading, right?
Yes.
So as Hussam's saying, I have to have -x here. Why? Because if I divide the leading by the leading, I should get -1. Plus what now? I have to say this is a plus b. And this b, we agreed earlier that the x-intercept is what is the 0 of the numerator. We mentioned this earlier. Now, how can I find b? We can use the order pair that is given, 3, 0. Can we substitute the order pair now? Replace y by 0 and x by 3?
Yes.
What will I have then? If we cross multiply, what's going to happen? Can I say 0 equal -3 plus b? Which means that b will be
3.
And we said all the time the x-intercept is the value of b. So what's my function now? I will say y will equal to what? -x plus 3 all over x minus 4. And this is our answer. If you have a question, raise your hand. Yes, Ali Saba.
Yes. Why you put x -4? For example, why don't you put 2x -8? For example.
Excellent, thank you. This is my next discussion. Thank you, Ali. I will answer your question right now. This answer is correct, Shabab. But sometimes he tries to trick you and change that answer. So this answer can be changed as follows. How can he change it? He can multiply the numerator and denominator by any non-zero real number that he likes. What will happen, Shabab, if I multiply by -1? Will the value change or will I have the same value? I'm talking about the value here. Will the function remain the same or will it change if I multiply by -1 up and down?
The same.
It's the same. If I multiply by -1, what do I get, Shabab? X minus 3 over what? Can I write -x plus 4 in this form, Shabab?
Yes.
So is this answer accepted? This is accepted. So both of these answers are correct. Or he can also multiply by any real number. I will say -x plus 3 over x minus 4, and he can multiply by, let's say, by 2. If we multiply by 2, what will the answer be? -2x plus 6 over 2x minus 8. Or he can multiply by -2, not only 2. So all these answers are correct. But in the exam, how should I know which one is the correct? Well, you have to look at the coefficient of x in the denominator. In the first solution that we found here, what was the coefficient of x in the denominator?
1.
I think it's 1. Now, if we look at the other solutions that we have found, what was the coefficient of x in the second solution?
-1.
So this means he had, since the coefficient of x is -1, this means he multiplied up and down by -1. What's the coefficient of x in the last solution? I'm talking about the denominator.
2.
So this means he multiplied up and down by what, Shabab?
2.
Multiplied by 2. So how do I know with what did he multiply? I have to look at the coefficient of x in the denominator. And I can multiply by that number as if I need. If you have a question. No questions, we'll proceed to the next one. In this example, he says find the equation of the function in the given graph, but the graph is missing. I'm going to bring it from the content library. I'm going to go to the content library now and bring the graph. It's this one. And we'll paste it here. Now let's read this. Again, he says what? Find the equation. From the graph, do you see a graph of a rational function or not, Yeshaban? Of course, the answer is yes. Now, who can tell us what's the vertical asymptote in this graph?
Y equal vertical, x equal 4.
X equal
2.
2. What about the vertical asymptote in our graph?
Y equal 4.
Y equal 4. Now let's form the function. Now who can tell us what should we write in the denominator?
X minus 1.
X minus 2.
X minus 2, which is the 0 of the denominator. The vertical asymptote is the 0 of the denominator. Type. Since the horizontal asymptote is y equal 4, this means if I divide the coefficients of x, they should give me 4. So what should the coefficient of x in the numerator be?
4.
It should be 4, because 4 divided by 1 is 4. And we say here this is plus b, and we said this b, what is it?
X-intercept.
The x-intercept. Do you see an x-intercept in the graph?
Yes, 0.
This is our x-intercept. So the value of v is what? So what's my function? Is this one. This is our function now. And we are done, of course. Yes, على السبب. Again by mistake. طيب. Now let me ask a question, Shabab. What if we have a hole somewhere, like at this point here, 0, 0. If I have a hole here, what will the function be?
Multiplied by
Multiply it by what?
the number of the hole. So we can take it as a common factor.
So what's that factor?
It will be multiplied by x.
If there's a hole at x equals 0, this means my function, thank you for your participation, it is correct. We have to multiply up and down by what now?
X.
By x minus 0, which is x. This will be our answer if there's a hole. I'm saying if there's a hole. Any questions? Type. No questions. I'll proceed now to the last part of this section, which is something called the slant asymptote. Well, do you remember we said for the horizontal asymptote we have 3 cases? If we read the third case, Shabab, what does it say? The third case, part C. If the degree of the numerator is greater than the denominator, what do we have? We have no horizontal asymptote. But now we have a special case. If the degree of the numerator is more than the denominator, we have many cases, but one of them is special. What's that special case? Please pay attention. Let's read this statement, Shabab. The degree of the numerator is 1 more than the degree of the denominator. If this happens, the rational function will have something called a slant asymptote, or sometimes we call it oblique asymptote. Slant in Arabic, what does it mean? Slant in Arabic means ma'il, ya shabab. Ma'il. So what does that mean, ya shabab? We will have a slant asymptote when, read the yellow statement one more time. If the degree of the numerator is 1 more than the degree of the denominator, in this case we will have what? A slant asymptote. And that slant asymptote is the quotient of the division. Do you remember how to divide the shabab? The quotient here will be linear. Why is it linear? Because the degree of the numerator is 1 more than the denominator. So if I divide, this will be linear. This linear function is called what now? The slant asymptote. Let's take an example to understand this. Look at this question here. What does he say? Find all the asymptotes. First of all, if I factor the numerator, is there anything to cancel with the denominator?
No.
No.
So if no, this means there is no whole, because I didn't remove or cancel any part. So this is x minus 5, x plus 1. So this means we have what here? There are no holes. Why no holes? Because we didn't cancel anything. What about the vertical asymptote now?
X equal 3.
The vertical asymptote is x equal 3. What about the horizontal asymptote?
No.
Here we have no horizontal. Why?
Because
The power of the numerator.
The degree of the numerator is greater than the degree of the denominator. Degree of a numerator is greater than the degree of the denominator. In this case, we don't have a horizontal type. But now, can you see that the numerator has a degree that is 1 more than the denominator? So in this case, we say we have what now? Something called what? Slant asymptote. Now let's find that slant asymptote. The slant asymptote is what now? Is the quotient of dividing. Now how can I divide? We have learned 2 methods to divide. We learned the long division and the synthetic division. Can I use the synthetic division in this example?
Yes, it's easy.
Of course, yes. Let's divide now. X squared is 1, I'm writing the coefficients now. 1, -4, -5, and we are dividing by what now?
3.
By 3. Let's see what's going to happen now. 1 will go down, then we have 3, -1, -3, negative what? -8. This thing here, what do we call it? This green thing. Is it the quotient or not?
Yes.
And if we remember, Shabab, this -1 was the constant, and the 1 was the coefficient of x. So can I write f of x now in this form? X minus 1 plus the remainder, which is -8 over x minus 3. Now my mission is just to know the quotient. What's my quotient here again? So I will say that y equals x minus 1 is what? A slant asymptote. And to convince you about this slant asymptote, I'm just going to graph it for you. Just give me less than 1 minute to graph it. So we can share the screen so that you can see the shape of the asymptote here. Just give me 1 minute to write the rational function and graph it. Just 1 minute show till I finish the graph. I'm just going to introduce the graph for you so that you understand the meaning of the asymptote or the slant. You are not asked how can we graph this. I'm done. خلاص. I'm just going to bring the graph so that we can discuss it. This is the graph that you will see right now. Let me just put it somewhere here. This is the graph. Of course, it's the red curve, Isha. Now, in this red curve, do you see that the blue line? You see the blue line, Isha? This blue line is what now? The slant asymptote. And again, slant means it's not vertical and not horizontal. Can you see that the red curve is getting closer and closer to that blue line?
Yes.
And it's not touching? So this is the meaning of a slant asymptote. Again, I will repeat, when will we have a slant asymptote? Sorry. Anyone can answer this question for me? When do we have a slant asymptote?
The degree of the numerator is greater one number.
Is 1 more than the degree of the denominator? Thank you very much. And how can I find the slant asymptote? It's the quotient of what? Of the division. Raise your hand if you have a question. Ali السبع.
Yes, if we have in the numerator x to power 4 and denominator x square, we will not have slant.
No, there is no slant asymptote. There is an asymptote, but it's not called slant. In general, the answer of the division is the asymptote. I'm talking about not the answer. So the quotient of the division is the asymptote. So if you have a degree 4 over degree 2, if you divide, the quotient is always an asymptote. But that quotient right now is of degree 2. So the asymptote can be of degree 2 or degree 3. But slant means it's of degree 1. Ahmed Abdul Khaliq, what's your question?
السؤال اللي قبل هذا.
Yes.
The whole is y equal x equal 0. Why
Yes.
why don't y equal 2?
Why didn't y equal 2?
X equal 2, sorry. Choose equal, X equal 2.
No, x equals 2 is already a vertical asymptote. We cannot have a vertical asymptote and a hole at the same point. X equal 2 is a vertical asymptote. The function is not defined there. I'm saying if there's a hole in the graph, what should I do to the function? At x equal 2, already it's given to me as a vertical asymptote. So I cannot assume there's also a hole at x equal 2, because already there's a vertical asymptote. So you cannot put a hole in the vertical asymptote at the same value for x.
So you multiply by X.
Yx, because it's x minus 0. What's the value of x that I have a hole at here?
X is equal 0.
So I will multiply up and down by x minus 0. If the hole is at x equal 1, I will multiply up and down by x minus 1.
Minus 1.
Okay?
Okay.
So by this we have finished section 3.6.